These are notes for section 7.6, factoring trinomials, where we have an ax squared, or what that means is that we have a number in front of x squared. In the previous videos, we factored trinomials where x squared was always 1x squared. And what that allowed us to do is when we had just an x squared, plus 6x plus 5, is as long as that x squared was a 1, we were always able to start factoring by putting x in x, because I know x times x will get me 1x squared. As soon as you put a number in front of that x squared, these problems become much more challenging. So the steps to factor a trinomial when you have a number in front of x squared are listed here, and I'll go through an example problem. It is lengthy, but as you work through it more and more, the process gets a little bit faster. And this is a surefire method to make sure that you can do A, then B, then C, then D, then E, then F, and factor it regardless of what the numbers are. So step one, factor a GCF if possible. Well, there's no number that goes into 3, 8, and 4, so that can't do that. Step two, multiply A and C together. And A and C, according to our equation, are the first and the last. So I look at 3 and 4, and I'm multiplying 3 times 4 to give me 12. Once I multiply 12, this is the number I'm playing the numbers game with. As in the previous section, numbers that multiply to C and add to B, or numbers that multiply to C and subtract to B. That's this step 3 here. So numbers that multiply to 12. 1 times 12, 2 times 6, 3 times 4. I'm looking for the combination that multiplies to 12 and will add back to 8. So which of those combinations will multiply to 12 and add to 8? Well, that, of course, is 2 and 6. So now that I know what my factors are, I'm going to take this b term, which is here in the middle, and I'm going to split it into the two factors. So this 3x squared, that stays. This plus 4, that stays. And what I'm going to do is take this plus 8, or I'm sorry, minus 8. I'm going to take this minus 8x and split it into minus 2x and minus 6x. Because if I were to combine like terms, 2 and 6 would give me 8. So all I'm doing is taking this middle term and I'm splitting it up into the two numbers that multiply to give me 12. Once we've split that middle term up, we are now into what's called factor by grouping, which is this next step. And this is really section 7.8. So we're kind of factoring two sets of notes here. But I think using factor by grouping gives students a method to do over and over and over. It's a repeatable process that kids can pick up on. It is lengthy, but as you do it, it gets faster. So factor by grouping. We group the first two terms together and factor the GCF. So I group this one and this one, and I look for a GCF. Between 3x squared and 2x, the GCF is x. What would be left over is 3x minus 2. All I did was look at my first two terms, and I factored out a GCF. Then I grouped the last two terms together and factor out its GCF. So I group this one, I group this one. Now I'm looking at the second half of my polynomial. And if you remember, we talked about x squared being positive. If we stayed with that same kind of idea here, even though we're not looking at x squared, we're looking at x, we could factor out a negative 2, because 2 would go into both 6 and 4. What would be left over is 3x minus 2. Now, if you notice, our two sets of parentheses are identical. This 3x minus 2 and 3x minus 2 are the exact same. If we factor by grouping correctly, that will always be the case. And that's what allows us to make this problem a little bit faster as we get moving. So I can now do what's called factor out a binomial GCF, which means a binomial I have two things, and GCF means they both share it in common. Okay, what does that mean? That means the stuff on the outside of the parenthesis gets its own set of parentheses. So this x is on the outside of the parentheses. This minus 2 is on the outside of the parentheses, so it gets its own set. And out of the binomial GCF, I'm going to keep one of them. And that's the factored form. If we were to multiply those two parentheses together, we would end up exactly where we started. And I understand there's a lot of work involved. It is lengthy. There's about 4 different ways that we could factor these types of problems. I have found that this, for me, in my classroom, is an efficient method that kids can repeat. It is lengthy, but we can get there. And I'll be happy to do another video, maybe I will, of other methods to factor these. So let's go through a couple of these. On number 1, technically. On number 1, we do not have a GCF. Okay, no GCF. Next step, multiply A and C together. 2 times 5 is 10, or negative 10. It doesn't matter how you call it here. I'm looking for numbers that multiply to 10. 1 times 10, 2 times 5. Of this set, which ones will subtract to give me 9? Well, that's 1 and 10. Once I find my factors, I can split it up. This 2x squared stays. This minus 5 stays. This 9 is going to be split between a plus 10 and a minus 1. Now, they're opposite signs because they need to multiply to be a negative 10, which means one of these numbers has to be a negative. The bigger number carries the sign in the middle. It follows the same sign rules that we did in section 7.4 and 7.5. Doesn't matter the order in which you put them in the middle. I could have put minus x first. It's going to factor the same way. Once we split the middle term, factor by grouping. The GCF between those two terms is 2x. What's left over is x plus 5. Again, at the top, if we factor by grouping correctly, these two parentheses are always going to be the same. So I don't actually have to go through and look for a GCF in the second half. What I could say is I know this set of parentheses is also x plus 5. The real question is, what could I put in the middle that when I distribute, I would end up with negative 1? That'd be minus 1. So the stuff on the outside gets its own set of parentheses. The stuff on the inside, I keep the binomial GCF. That's it. On number 2, no GCF, multiply A and C. That's 24. Looking for numbers that multiply to 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Which of these combinations will add to 11? Well, that would be 3 times 8. 3 times 8 multiplies to 24, adds to 11. Once I have my factors, I split it up. The 4x squared stays, the plus 6 stays. This minus 11 is going to turn into minus 3x, minus 8x. And they're the same sign because they have to add. Same sign, add and keep. Factor by grouping. Group the first two together. The GCF is x. What's left over is 4x minus 3. Whatever your first set of parentheses is, your second one has to be that. If it's not that, it can't be factored. We are asking ourselves, what could I put in the middle that when I distribute, I would end up with minus 8x? What times 4 would give me minus 8? Well, that's minus 2. Stuff on the outside gets its own set of parentheses. Stuff on the inside, I keep one of them. Factor by grouping in order to factor more difficult trinomials. Let's do 2 more, and that'll be it for the notes. On number 3, 6, 14, and 4 have a GCF. The GCF is 2. 2 would go into each of these. Now, you could factor this without pulling out the GCF. It is possible. The problem is your numbers are going to be much bigger to work with, and the combinations are not as easy to find. So I always recommend factoring out the GCF. Once you factor out the GCF, you multiply A and C together to get 6. Looking for numbers that multiply to 6. And again, I got 6 from 3 times 2 or 2 times 3. 1 times 6 will give me this 7. So this 2 is just going to carry along the problem the whole way down. This 2 is now going to be part of our answer at the end. I write the first term. I split the middle term. Oh, that's a plus sign there, isn't it? I split the middle term. and I write my last term plus 2. So I took this 7 and I split it up. Factor by grouping. Group the first two together. The GCF is x. What's left over is 3x plus 1. Whatever that parentheses is, so is this one. What times 3 would give me 6? Well, that would be plus 2. Stuff on the outside gets its own set of parentheses. Stuff on the inside, I'm going to keep one of them, factoring out a binomial GCF. And we can't forget about this 2 as part of our answer. It is definitely part of our answer. If I wanted to be technically correct about this middle step here, I should have put it in brackets. On number 4, x squared is negative and it asks us to solve. So I first need to factor out that negative sign. That's from a previous video. We would like x squared to be positive. And once I factor out the negative, now I'm factoring. Numbers that multiply to 40. So that's 1 times 40, 2 times 20, 3, 4 times 10, and 5 times 8. Which of these combinations will subtract to be 3? That's 5 times 8. So again, this negative is just going to carry through the problem, just like the 2 did on number 3. And I rewrite my polynomial. I expand it. That would be 5x squared minus 5x plus 8x minus 8. And again, the signs are important here because I need this 3 to be positive. And the only way to make 3 positive is if the bigger number carries the sign. So it'd be minus 5 plus 8. Once I've split the middle term, factor by grouping. Between 5x squared and 5x, the GCF is 5x. What's left over is x minus 1. Whatever this parentheses is, so is that one. What times 1 would give me plus 8? That'd be 5x plus 8. The stuff on the outside gets its own set of parentheses. The stuff on the inside, I factor out the binomial GCF, and this negative is part of the factorization, but that negative isn't going to affect what my answer is. Once I have this factored, I can set up my 2 equations using the zero product property. Both of them equal to 0. Solve them both. Subtract 8, divide by 5, you will get negative 8/5. Add 1, you would get positive 1. Yes, it is a lengthy process. There are other ways to factor these. You can find them online if you would like. And maybe I'll make another video talking about the guess and check method or using the perfect square method. Hope that helps. Appreciate you, and see you on the next one.